Okay, on this question, they give us a function and they want us to find f prime, the derivative. And in the end, they want us to type our answer without fractional or negative powers. Okay, well, the first thing, whenever I have a square root, I always rewrite those. Let me mention that. So we always just makes it easier to do the derivative. We always rewrite the square root if we have anything inside of a square root. We just rewrite that as that inside whatever to the half power. So you need to know that a half power is the same as the square root. So I'm going to do that first off. I'm going to rewrite f of x equal 4 parentheses 6x to the fourth plus 9x to the 7 to the half power. Okay, so rewrite it as a half power. I know in the end we can't have that, but it's helpful in the middle. Okay, so that's a rewrite. That's not a derivative, in other words. Okay, now next step. Now we're going to take the derivative. So the first step was not the derivative, it was just the rewrite. Now comes the derivative. How do we do the derivative? Well, we have to realize we have a function inside and outside. So this is the inside function, and this half power. This is the outside function. So how do you take the derivative when we have like an inside and an outside function? Well, that's called the chain rule. Chain rule, which is what they say right here. Chain rule. And so when you have an outer and then like an inner, as this means this O stands for outer. The I is the inner. So if you have an outer and an inner function, what do? You take the derivative of the outside function, and then you keep the inside the same, then times the derivative of the inside function. That's the chain rule. It's like a link. The original derivative links to the next one, like links in a chain. So here we go. So let's do that. So first off, the first thing to do is derivative of the outside function. So the outside is this half power. So he's going to come right there. What's half of 4? 2. And then subtract 1 from that. That's going to become minus a half. The inside function doesn't change. Just bring it right there. That's the inside function, right? So far, so good. We did the derivative of the outside, right? The half came down. Half of 4 is 2. Subtract 1 from the power. That's 1 half, take away 1 is minus a half, right? And keep the inside function the same. There it is. Times, we're not done yet, times the derivative of the inside function. So now I'm going to take this and I'm going to take the derivative of the inside function. So take this guy first off. The 4 goes right there. 4 times 6, 24. Subtract 1 from the power. X to the third. Then the 7 hits the 9. 63. Subtract 1 from the power. X to the sixth. And that is, oh, we're not done yet. We got to clean it up like they told us to. So, but is this making sense so far? So again, what I do, my first step was to rewrite because I don't want roots. I want to make it a half power. Then you do this is an inside function, outside function. You do the outside first, or to the outside, so the half comes there, makes it 2. Keep the inside the same. It's the I. And then subtract 1. That finishes the outside function derivative. Then go times the derivative of the inside function. Just this inside function, just him, nothing else, just the inside function. His derivative is 4 comes down, 24, lower the power by 1 becomes 3. 7 comes down, 63, lower the power by 1, 6. So now we remember they said type your answer without fractions and without negative exponents. See how we have a negative fractional exponent? Can't do that. So we got to fix that. So now it's, I'll just call it clean up or rewrite. So what's going to happen? Well, make a fraction for us. So basically, the 2 and the 24x to the third plus 63x to the sixth, that's going to stay on the top. And the 6x to the fourth plus 9x is going to go to the bottom, and the power is going to become positive half. I got one more step, and I'll do it right here. But do you see what just happened there? Do you remember that negative powers go to the other side of the fraction? That's the key thing you got to remember. If you have like, here, I'll scribble it over here. If you have like x to the negative 3, that's 1 over x to the positive 3. Remember, negative powers are negative. They're unhappy where they're at. They want to jump to the other side of the fraction. After they make the jump, then they're happy. They're like somebody unhappy at their job, jump to a new job, then they're happy. So negative powers want to jump down, or if they start down, they want to go up, whatever. They want to go to the other side of the fraction, then they become positive, right? So if you have x to the negative half, for example, that's going to become 1 over x to the positive half. It's going to jump to the bottom. That's what happened here, right? This negative half power on this whole 6x to the fourth plus 9x. Oh, did I lose the 7? I did. Forgot that 7 power right there. There we go. Anyway, sorry about that. So that whole thing is going to jump down to the bottom and become a positive half power, but we still can't leave that. No fractions, fractional powers, I mean. So last step here is going to be to keep the top the same, 24x cubed plus 63x to the sixth. The bottom now is going to become the square root. The square root of 6x to the fourth plus 9x to the seventh, right? Because that's what a half power means, as we talked about earlier, right? A half power on anything means the square root of that thing. And they want us to write it this way because they said no fractional powers, no negative powers. So we had to first have that negative power, had to jump to the bottom and become positive, and then we got to say, okay, now a half power is a root. So here it is, the answer, no negative powers, no fractional powers. That's exactly what we see they have right there. So that's how we do that.